and not an IV drug user. Okay, and if you guys can help me out, I think that this was, what was this, 15? And this was 35? And this was, if you remember, that was 35. And this was 120, right? Whoops, 120, I think. 125. Yep, it's got to add up to 100. Okay, 125. Right, that makes sense because it adds up. We said that there were 50 IV drug users. There were 150 non-IV drug users in this population. There were 40 people that were HIV positive, and there were 160 that were not. That's where we got our 20% prevalence from. Okay, so here is our 2x2 table. Actually, I got to open this up a little bit to get access to this. Okay, here's our 2x2 table. Let's neaten it up a little bit. Okay, so now let's look at this. What's the, I'm just going to look at the IV drug users for now. What is their risk? Yeah, you're right. Yeah. 25. Okay, yep. Yeah, they got me online too. They picked it up online also. Okay, what's the risk of having HIV if you're an IV drug user? Well, I'm going to define the risk. I'm going to say the risk is equal to, well, 15 out of 50 people that are IV drug users are HIV positive. So 30% of them are IV positive. So the risk of having HIV, if you're an IV drug user in this population, is 30%. Well, what's the risk if you're not an IV drug user? Well, that risk is equal to, that risk is equal to 25 out of 150 people that are not IV drug users. They maybe have other risk factors. Their risk is about a little less than 17%, right? 25, is that right? 25, it's 1/6, right? Yeah, 20, it's 1.6 or 7%. Okay, so now the risk if you're not an IV drug user is lower than the risk if you are an IV drug user. I'm gonna actually do something here that helps me understand how the risk for one group compares to the risk for the other group. I'm going to create something called a risk ratio. Okay. A lot of people also call it relative risk. Right? So they're both RRs. You see RR is equal to a lot of times in studies. I'm going to take the risk ratio. So let's see. If you're an IV drug user, your risk is 0.3, 30%. If you're not an IV drug user, your risk is about 17%. I'm going to divide one risk by the other risk. I'm going to see a ratio, relative. Anytime you say a risk ratio, you say somebody says ratio, you're dividing one thing by another. Okay, is 1.8. Well, what does that say? That says that the risk of having HIV is 1 times as great if you're an IV drug user versus if you're not an IV drug user. What would we expect that number to be if there was no association between IV drug use and HIV? Well, we would expect the same rate of risk for the same rate or risk for IV drug users as for non-IV drug users. So this might be 0.2 and this might be 0.2. You'd expect it to be 1, right? If there's no association, we would expect this risk ratio to be 1. You would expect the risk for IV drug users equal to risk for non-IV drug users. So therefore, you would expect that the relative risk, 1 divided by the other, is going to be equal to 1. So we have to say to ourselves, okay, is that equal to 1 or is it not equal to 1? But again, we have the same problem as before. In a perfect world, that would come out exactly right. It would come out 1 all the time. But when we really sample a population randomly, we don't expect to get a perfect outcome for what represents the population. So we might get an outcome of 1.1 or 1.2 or 1.7 or 2.6. How big is big enough for us to say that there's no association between these two? Okay, so what's our hypothesis here? Our null hypothesis, right? What's our null hypothesis? That there's no association between the two of them. How can I say that in terms of relative risk? That means that the relative risk is equal to 1. No association means the relative risk is equal to 1. Our alternative hypothesis is that the relative risk is not equal to 1. Right? So what we need to prove is that the relative risk is not equal to 1. So this number has to be big enough that we are 95% certain that the difference is because there really is a difference between two populations and not just due to chance when we took the sample. The chances of being wrong, if we reject this null hypothesis, has to be less than 5%. Okay, how can we determine that? Well, this is kind of a proportion. When we had a way to figure out what the probability, we could compare one to, like one proportion to another proportion using kind of a t-test or binomial distribution. It's going to get a little complicated here for us in this particular case. I'm not going to ask you to do that in Excel. SPSS is going to do that for us. Okay, so for the purposes of this analysis, keep in mind that we're examining whether or not a proportion is equal to 1 or not equal to 1. And based on the sample size, remember the p times 1 minus p, and so on and so forth, as the sample size is involved, based on the sample size and how big this ratio is, we should be able to calculate not only the probability of getting this outcome if there's no association, p is equal to some number, hopefully less than 5%, but also a confidence interval. Now, if I calculated a confidence interval for the relative risk, what would I want that confidence interval not to include? We don't want that confidence interval to include the number 1 because we want to prove that it's different than number 1. So if our confidence interval for the relative risk is 1.2 and 2.3 to 2.3, we're 95% sure that the true a relative risk is between 1.2 and 2.4. That means we're also 95% sure it's not 1. So we could reject the null hypothesis either by knowing the probability of getting a number as big as 1.8, but also by showing that it's outside of that 1 is outside of our confidence range. Okay, who here plays the ponies? I know OTB is closed now, so goes to the track every once in a while, watches the Belmont Stakes if there's a Triple Crown winner. Anybody here actually go do that, right? You watch the ponies? When you go to the track, they don't talk about risk. They don't say, the risk of this horse winning is bigger than the risk of this horse winning, right? What terms do they use? They use odds. Well, they calculate odds in a funny way. Okay, the way they calculate odds is if they say the odds are 4 to 1, they're not saying that the odds of this horse winning is 4 times greater than the odds of the other horse winning. What they're saying when they say the odds are 4 to 1, they're saying that if the race was run 5 times, this horse would win 1 out of those 5 times, would lose 4 times, win once. If the odds are 15 to 1, they would say that if you ran the race 16 times, it would win once, lose 15 times. Okay, kind of funny way to look at stuff, right? Well, believe it or not, that's the more popular way to look at this idea of risk between these two, or rates between these two groups. You tend to see the term odds ratio used more often than the term relative risk. There's a bunch of technical reasons for that, but I agree with you. I know what's going through your mind. If this, some of you have taken stat courses before and may have been exposed to this before. If you haven't been exposed to this before, you say to yourself, why not? It's so much more intuitive using this idea of relative risk, right? Than this idea of odds ratio. Why do it that way? But there are some technical reasons for doing it. Okay, so I'm going to calculate now, instead of calculating the risk for these two outcomes, I'm going to calculate the odds for these two outcomes. So I'm going to go up here and I'm going to go to odds. I'm going to make another column here called odds. Okay, so let's take a look. This is the area that we're interested in right here. Okay, so what are the odds of, if you're an IV drug user, what are the odds of your being HIV positive? Well, it's going to be 15 times over 35. 15 of the people have HIV that are IV drug users, 35 don't. So the odds of a person, odds are of an individual having HIV is 15 to 35, or in other words, 0.42. Okay, a bit different than the risk, but it's kind of like in the same genre, right? Kind of like a similar thing, but we get a slightly different number. So what would you tell me? What would the odds be for non-IV drug users? Anybody want to hazard a guess? What two numbers? 25 over, what'd you say? 125, bingo, that's it. That's as hard as this gets. Okay. How are you guys doing online? You get that online? Okay, the odds are, now, what did I do here? I calculated the risk ratio. Now I'm going to calculate the odds ratio. And what is the odds ratio going to be equal to? It's going to be, since it's a ratio, it's going to be one thing divided by another. It's going to be 0.42 divided by 0.2. So my odds ratio is 2.14. The odds of being HIV positive if you're a drug user is 2.14 times as great as the odds, not risk, odds of being HIV positive if you're not an intravenous drug user. Okay, the real key here though is if there is no association, what's our expectation that the odds ratio is equal to? The odds for non-drug users should be the same as the odds for drug users. Right. Again, it's going to, our null hypothesis odds ratio is equal to 1, and alternative hypothesis odds ratio does not equal 1. Okay, and it does not equal 1. So we're in the same boat. We need to evaluate what's the likelihood of getting this big an odds ratio, just by chance that there's really not some association, right? Just because of the way we sampled, and also maybe calculate a confidence interval for the true odds ratio for the entire population based on the sample size and the numbers we got, and see if that is indeed also different, exclude 1. In other words, do the same thing we would do with the relative risk. Yes?
So how did you get those two numbers?
I made them up.
Oh, okay.
Like I said, I'm not going to ask you to calculate them for chi-square, an odds ratio and relative risk, but you're going to use SPSS to do it. Okay, we're about to do a demonstration of that in a minute or so. If it doesn't include 1, you've proved with 95% certainty that it's different than 1. You've excluded 1. So that means that it's less than 5% chance of being wrong if you reject the null hypothesis. Okay, or you could actually calculate a p-value, which SPSS may do also, a probability of getting that number, if there's no association. And if that probability or significance is less than 0.05, you can reject the null hypothesis also. So we got 3 ways of dealing with this. We got one way is to use the chi-square value, right, to demonstrate there's an association. We got relative risk, which is a nice intuitive way of demonstrating, and we have odds ratio. Well, why didn't I just stop at chi-square? I didn't stop at chi-square because the relative risk and the odds ratio give us a very intuitive, easily explainable picture of how important this exposure is. It looks like you're twice as likely to be HIV positive if you are if you're an IV drug user than if you're not an IV drug user in this population, right? Well, why is that so nice? Well, now if I am trying to communicate this information to someone else, if you take statins, you will be, or let me put it this way: if you have high cholesterol and you don't take statins, you'll increase your risk of having a heart attack in the next 10 years by 10%. Right? In other words, your risk is 1.1. You're 10% more likely. So that's what odds ratio or relative risk give you. It gives you a way to communicate the magnitude of the difference in the risk from that behavior or that exposure. right? So it's nice rather than oh, listen, chi-square says you're more likely to have a heart attack if you don't take this drug. Well, how nice for chi-square. But the relative risk and the odds ratio communicate this a lot better. Okay, so let's talk about that for a second. You see that all the time, don't you? Right? Like in other words, the risk of if you are obese, the risk of a heart attack is 30% more, right, in the next 10 years. And at a certain age range, 30% more in the next 10 years. Keep in mind now. But now let's talk about statins, right? A lot of controversy about statin these days. You walk into, I was talking to somebody about this. You walk into a doctor's office and you're over 50, there is a better than even chance you're walking out with a prescription for a statin, right? Why? Because they've gotten progressively more rigorous about trying to reduce cholesterol levels, especially bad cholesterol levels, because they see it has an impact. Okay, so let's say you walk in there, you're 50 years old. The risk of your having a heart attack in the next 10 years might be 5%, 1 in 2, say 1 in 20, right, for argument's sake. If you take the statins, you reduce your risk by, let's say 10%. I'll be generous. Maybe they don't even do that, right? You reduce your risk by 10%. So instead of having a 5% risk, you reduce your risk by 10%. Now you have a 4.5% risk. Well, now the statins, trust me, statins are not that pleasant for a lot of people. They can cause constipation, muscle aches. They can cause all sorts of side effects. Some of the side effects are dangerous from statins. There's a type of muscle deterioration you get from statins that release things into your bloodstream that can damage your liver and kidneys, right? So statins are not that innocuous a drug. So why are doctors prescribing this if it only reduces my chances of having a heart attack in the next 10 years from 5 in 100 to 4.5 in 100? Why are they doing that? Well, don't think of it from the perspective of the individual. If you can reduce the number of heart attacks in this country by 10%, you may eliminate 100,000 heart attacks every year, right? And the number of deaths and the number of hospitalization and the costs and so on. So from a health perspective, that's an enormous impact. From an individual perspective, it's not as dramatic a difference in terms of risk. But you guys are not you're not doctors. You're not in the individual business. You're in the public health business, right? So it's an important public health initiative to have people more aggressively treat cholesterol, right? So, and there's also, then you also talk about costs and so on and so forth. But again, the cost balance suggests that you want to do this. And how's the easiest way to explain that, or the easiest way to describe what the effect of this will be? Odds ratio. And you'll see a lot of abstracts. If you read studies, you'll see a lot of abstracts that will talk about an intervention. Let's say something that involves educating parents about asthma risks for children or something like that. And then they'll evaluate, well, the group that got the training, group of parents got the training on how to reduce their children's exposures or treat them and so on and so forth. Well, maybe they had 3 emergency room visits. Maybe they had this number of emergency room visits per year, and the other group had a certain number of emergency room visits per year. So you have trained parents, not trained parents. You have whether or not they had an emergency room visit or didn't have an emergency room visit during a year or something like that. And you may be able to see that there's a relationship. And maybe you'll be able to demonstrate that there's 30% fewer emergency room visits because they were trained or not trained or whatever. So it's a good way to describe what the difference in risk is, right? So let's actually put this into play using